Hello student, good morning. Today I am going to discuss formal charge. Formal charge, this is very important concept, and it is required to understand the stability of the molecule, shape of the molecule, and many questions are asked on its concept. Then formal charge, I am talking about the formal charge. Lewis dot structures in general do not represent the actual shapes of the molecules. In case of polyatomic ions, the net charge is possessed by the ion as a whole and not by a particular atom. It is, however, feasible to assign a formal charge on each atom. The formal charge of an atom in a polyatomic molecule or ion may be defined as the, listen carefully, may be defined as the difference between the number of valence electrons of that atom in an isolated or free state. Means simply difference between the number of valence electrons and the number of electrons assigned to that atom in Lewis structure. Again I am telling you, it is defined as the difference between the number of valence electrons of that atom and the number of electrons assigned to that atom in the Lewis structure. Mathematically, you can as a formula you can write like that. First, that a formal charge is equal to, formal charge on an atom is equal to total number of valence electron in the free atom. 2 times you have to do minus, 2 times. Then first time you have to minus total number of non-bonding lone pair electrons. Non-bonding electrons, or you can tell lone pair of electrons. And second minus you have to do that half of total number of bonding shared electrons. See, again I am telling you, formal charge of an atom in Lewis structure, that is equal to total number of valence electrons minus lone pair of electrons, or you can tell total number of non-bonding. Lone pair will not take part in bonding. That's what is called non-bonding. Lone pair is called non-bonding because it is not taking part in the bond formation. Minus, one more times minus, half of total number of bonding, that is the shared electrons. Means you are considering both non-bonding electrons and bonding electrons. Both you have to subtract from total number of valence electrons. And simple formula of formal charge is equal to valence electrons minus non-bonding electrons minus bonding electrons. Simple formula. Formal charge is equal to valence electron minus non-bonding electrons minus bonding electrons. Now, by one example, I want to clear it. That try to understand. Only actually it should make habit to calculate all the things in mind only, without use of pen and paper. Because in competitive examination, no pen, no paper will be allowed. No calculator. They will take your calculator only before entering the examination hall. Then you should make habit to calculate all the things in mind, and also make habit for imagination of diagram, picture, reaction. In mind only you just make a habit to understand. This is a very good habit. Then now just I am explaining it by one example. That is the O3, ozone, O-Z-O-N-E, ozone. It is found in the, that in a space. It absorbs the UV light. Due to that, UV light is not able to come to the earth. Now, despite that, due to depletion means some hole became, some ozone layer is coming. Due to the depletion of ozone layer, some UV light is coming towards the earth. Ozone, there's a big layer is there in space far from the earth. Now, just O3, I am talking about 3O is there. 3O is there. Then you can number as first oxygen, second oxygen, third oxygen. Is first atom of oxygen, second oxygen, third oxygen. Okay. Then formal charge, how will you calculate? Then for that you have to write first dot structure, Lewis dot structure you have to write. Then what is the bonding? Between the two oxygen, double bond is there. Between the two oxygen, double bond is there, and with the third one, single bond is there. 3 oxygen atoms are there. Between the two, any two, double bond is there, and with the third one, single bond is there. Then one double bond and one single bond. This is the you can say a structure of ozone, just like a V structure, and it will look like a V. Shape will be just like a V shape. Then now how will you calculate these things, formal charge? Then here again, if you will see the dot structure, then you will find that in one oxygen, one lone pair of electron is there. In second oxygen atom, 2 pair of electrons are there. And in third oxygen atom, 3 pair of electrons are there, lone pair of electron. In the first, only one lone pair. In the second, two lone pair is there. And in third, 3 lone pair is there. Then one lone pair means 2 electron. 2 lone pair means 4 electron. And 3 lone pair of electron means 6. Okay. Then in ozone, 3 atoms are there. Then in each atom, lone pair, I told you, in first, 1 lone pair. In second, 2 lone pair. In third, 3 lone pair, means 6 electrons. First one 2 electrons, second one 4 electrons, third one 6 electrons. Then easily you calculate formal charge by following the formula. Then formal charge equal to, I told you, formal charge equal to valence electron. Valence electron, then oxygen valence electron is 6. Then 6 minus non-bonding electron. Then in the first atom, 2 electron is non-bonding, means one pair is there, lone pair, only one. Then 2. Then 6 minus 2. Again, third one, that is I told you half, means minus half of bonding electron. Then bonding electron, in case of first atom, I told you between the first and second atom, a double bond is there, means 4 electrons are involved. Then now bonding electron is, number of bonding electron is 4. Then half into 4. Half into 4. Then now simply you simplify it. Then 6 minus 2 minus half into 4. Half into distinct. This case 6 minus 2. Non-bonding is 2 electron. 1 pair means 2 electron. And distinct bonding, how many electrons are there? Then it will be 6. 6, how 6? Let me think. That you are considering for the central oxygen atom. Central oxygen atom means first atom you are considering. Then there central atom means first atom. Then it is making total 3 bond it is making. One double bond, with second one double bond, and with third atom single bond. Then total 3 bond it is making, means 6 electron. The number of bonding electron is 6. Correct? 3 ozone molecule, 3 atoms are there. One is the center and 2 are in the corner, just like a V. Then second and third, second 2 pair and third 3 pair. And in the middle, means center, only 1 pair. Then that oxygen is making double bond with the second one and single bond with the third one. And so total bond is 3. The 3 into 2, 6 electron. Then formal charge for this oxygen, means central metal, number 1, what we are given simply. First oxygen atom, that 6 minus 2, non-bonding electron is 2, minus 2, minus half into bonding electron. Then bonding electron is 6, because one double bond and one single bond. That central atom of oxygen is making bond with other 2 atoms. Then one with double bond and third one with single bond, and 3 electron and 6 electron. Then formal charge equal to 6 minus 2 minus half into 6. Then do simple simplification. Then you will get 6 minus 2, that is the 4. From the 4 again minus half of 6 means 3. Half of 6 means 3. Then 4 minus 3, that is equal to 1 plus 1. This is the formal charge for central oxygen. Like that way you can calculate for the second oxygen and third oxygen. Then second oxygen, again same formula, that is the valence electron is 6. 6 minus, here non-bonding electron is 2 pair is there, lone pair 2, means 4 electron. Then 6 minus 4, that become minus 2. 6 minus 4, that is the 2. Again minus half of bonding electron. Then for the second electron only double bond is there, because it is making bond only with first atom of oxygen. The double bond is there, only one double bond. Then 4 electron, then half of 4, that is the 2. Then your this will become how much? Then 6 minus 4 minus 2. 6 minus 4 minus 2 means 0. 6 minus 4 minus 2, then 6 minus 6, that is equal to 0. And second you can say oxygen got 0 formal charge. Now like that way third which has 3 pair of electron, lone pair of electron. Then in this case, I told you first and third, they are making only one bond, single bond. Then one single bond means 2 electron. Then here you will write again same way, valence electron is 6, non-bonding is 3 pair means 6, then 6 minus half of the how many electrons? For third one only 2 electrons, because only a single bond they are making. First and third only one bond is there, then 2 electron, then half of 2 is equal to 1, then it became 6 minus 1, then it became minus 1. 6 minus 6, both will cancel, then only minus 1 will remain. Then this is the way how to calculate formal charge. Question is asked. See, if we are going to, if we want to compete any competition, tough competition, then if question is asked like this type of things, you can't escape. Some student escapes lattice, this thing, not lattice, formal charge. But if you want to score highest score, you want to become topper, highest scorer, then any question you have to answer. And for that time, this type of understanding, question, terminology, all are very, very important. Then now ozone molecule, on ozone molecule you can write the charge. Then O3 is there. Now I told you just like a V structure, O, O, O. Then between the 2 O double bond and third one, with third one, first and third only single bond is there. Then on central metal you calculated how many charge? Then plus 1. First time what you calculated? Plus 1. Second time you calculated 0. And third time you calculated minus 1. Then on ozone you can write the charge with first atom means central 1 positive. For second nothing you will write because it is 0. And for third atom you will write minus, only 1 minus. Then this is the method how to calculate formal charge, I told you. And now again its importance you can understand. I told charge decides the shape of the molecule. That's why it has importance. And other things, it also tells about the stability or instability. Then now you listen. Formal charges, this is formal charges help in the selection of the lowest energy structure from a number of possible Lewis structure for a given species. If suppose a structure, this dot structure, Lewis dot structures are 2, 3 are there, then which one is the lowest? Which structure has the lowest? Lowest means stability. That structure will be stable and that will be the final structure. Resonance will be there. Finally resonating structure, final out of 3, one resonating structure will be there. That is actually most stable. But I am telling that which structure has the lowest energy, that will come, that structure will be the stable, as most stable. And this you can calculate by the formal charge. Then formal charge helps in the selection of the lowest energy structure from a number of possible Lewis structure for a given species. Generally, the lowest energy structure is the one with the smallest formal charge on the atoms. Atoms, not only one atom, atoms. Smallest formal charge on the atom, that is the means lowest energy structure is the one with the smallest formal charges on the atoms. The formal charge, what is the formal charge? Again you listen, very simple things. The formal charge is a factor based on a pure covalent view of bonding, in which, and in bonding what happens, sharing of electron, equal sharing of electron, equal sharing. If one either they will share one both, two both, or three both, like that way. Then the formal charge is a factor based on a pure covalent view of bonding, in which electrons pairs are shared equally by neighboring atoms. I have discussed. Now again I am going to discuss, I can say, most important topic, and that is from that concept in IIT, either main or advanced. The question is not fixed. Little tough question they will ask in advanced, but sometimes in main also they are asking, because it will be, if it is not very tough, then they will ask in both. Then it depends upon the question setter where they will set. But I am today, just now I am going to discuss that many question is asked only from this limitation of octet rule. I told you octet rule has also limitation. It is useful only for the second period, starting from lithium to halogen. That is the first period, that only hydrogen and helium is there. Second one, it actually applies on the second one. Second period mainly it applies. Why it applies only for second period, not for third, fourth, fifth, sixth? Because in the second period only S and P orbitals takes part in the bond formation. But third onward, means including third, fourth, fifth, sixth, D orbitals will also involve in bonding. In bond formation. That's why this octet rule will not work there. I will tell here. Okay. Then now listen carefully, because concept I will tell you, and it is very, very important to solve the many difficult question. And this examples what I will tell you, you also keep in mind. If you want to qualify IIT medical, then this concept you have to remember. Examples also you have to remember. Okay. Now listen carefully. The octet rule, though useful, is not universal. First point, it will not apply everywhere. It is quite useful for understanding the structure of most of the organic compounds, and it applies mainly to the second period elements of the periodic table. There are three types of exception. Exception questions are always important. Wherever you see exception, it means that question will be asked. 99% possibilities in a tough examination. Normal examination they will not ask, but in tough examination exception is important. Hence always you should give importance for that exception. Okay. Then now three types of exception is there for the octet rule. Then first exception, the incomplete octet of the central atom. Incomplete, because sometimes octet will be not 8 will not have central atom will not have 8 electrons. They will have less than 8 electrons. That's why it is called incomplete octet. It is not completed, but sometimes molecule will exist. Then how? I will tell you some these things concept how they are without 8 electrons also it is existing. Okay, molecules existing. What is the reason? I will tell you. It is high level, but I will tell you. Then now here you understand first exception, the incomplete octet of the central atom. In some compounds, the number of electrons surrounding the central atom is less than the 8. This is especially in the case with elements having less than 4 valence electrons. Correct? This is important things I am telling you. This first exception incomplete octet happens generally in the case with the elements having less than 4 valence electrons. Then who are less than 4 valence electrons? You have to think. In mind you think whose electrons are this less than 4. Valence electron 4. Which element? Then you know that element is lithium, beryllium, boron. Actually, many questions are asked from the lithium, beryllium and boron. Okay, many questions. Hence, if you are talking about the lithium, beryllium and boron, you should be careful. You think, and main reason is for less number of electron and a small size. Okay, and a positive charge is less on the nucleus, and atom is small. That is the number of electrons is also less. This is the main you can say reason. They are closer to nucleus, hence nucleus is attracting the electrons. They are bonded strongly. These are the general, I am telling you, reason why these are in exception in comparison to the others. Because others have new orbits will open, number of electrons will increase, positive charge will also increase, size will be big, ionization energy will be less. Like that, that is coming general, but it is a somewhat particular exception. Then I told you whose valence electron is less than 4. Then that element or molecules from that element that will show this exception. Means the central atom will not have octet. They will not have 8 electrons. Maybe less than 8 electrons. Not maybe will be. Then lithium chloride, LiCl. Lithium 1, lithium 3 electron is there. Then 1s square 2s1. Last orbit only one valence is there. Then valence electron is only 1. Hence it can make only single bond. Then LiCl, chlorine that requires only 1 electron. Then LiCl. Then here octet is not completed, only 2 electron is there. Now BeS2, beryllium hydride, already I discussed. BeH2. Then here you can see 2 bond is there. Beryllium is making last. In beryllium, how many what is this thing's valence electron? Then beryllium 4 is there, 1s square 2s square. Valence electron is only 2s square. Then these 2 beryllium, 2 electrons of beryllium, they will make 2 bond with each H. 2 H is there, then with each H single bond. Then 2 plus 2, total 4 electrons are there in the middle with beryllium. Octet is not completed. Like that way, boron trichloride, BCl3, boron trichloride. Then here again boron has 5. Then 1s square, 2s square, 2p1 means outermost orbit. That is the 3 electrons are there. 1s square means first orbit. 2s square, 2p1. then S and P both you have to consider. Then 3 electrons are there in the second orbit. That is, the valence electron is 3. Then it can make maximum 3 single bond. Then that is actually happening. Then chlorine is there. Then BCl3 it will form 3 bond. BCl, 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 single electron. They will share chlorine 1 electron, bromine electron 1 electron. Like that way 3 bond it will form. Then now 3 bond means 6 electron. The boron has only 6. Central atom is boron. It has only 6 electron. Then see here also octet is not completed, incomplete. Then these 3 example is asked in examination. Here I want to tell you boron this like that way BCl BH3 also you can make that is called boron BH3 boron trihydride, but this is you can say isomer. It is very weak. BH3 is very weak. That's why its dimer is strong. B2H6. B2H6. Then here for this is called a boron. B2H6 is called a boron. Here 2 points I want to tell you. This is advanced knowledge that because generally it is studied in higher level, but here I am telling you sometimes in IIT they are asking. First things that about its structure, that it is a dimer. BH3 is isomer, it will exist. Just make it a double B2H6. First point. Second point, it has banana type of structure. Fruits, banana which you are eating, that banana type of structure. Third important point, that till that I have told you that for single bond formation 2 electron is required. Till date you are knowing these things. Minimum 2 electron is required to make 1 bond. For double bond that 4 electrons, and for triple bond 6 electrons are required. For minimum 2 electrons required. Till date you are knowing. Now new things I am telling to you, that sometimes by single electron also bond can be formed. Only by a single electron. Example, that is in boron only. Boron only. This 3 point you keep in mind. That's why question is asked. Question is asked in all tough examination, difficult examination. This question is asked. Okay. Even in sometimes based on this concept, but they will ask little more complicated, but concept will be simple things. Now they will ask for IIT, but now writing they have to prove it by making the diagram and other things for the CSIR student. Okay. And sometimes UPSC simply they will ask what type of structure it has. Medical also. Okay, the question has no limitation where they will ask concept is important. Now second exception I am telling you, odd electrons molecules. First exception I told you, the incomplete octet of the central atom. Second, odd electron molecule. Okay, then odd electron molecule. Now by the heading only it is clear, odd electron molecule. Then here, listen, in molecules with an odd number of electrons. Molecules I am talking about, not atom. In molecules with odd number of electrons, like nitric oxide NO, nitric oxide, and nitrogen dioxide Na2, the octet rule is not satisfied for all the for all the atoms. It will not satisfied for all the atoms. Now odd electron molecule. Then odd electron molecules means what? In the molecule, atoms are required to make the molecule. Atom is required. Then any one atom, they will have odd number of electrons. Okay. Then first example is NO, nitric oxide. Question is asked. That's why you listen carefully. Nitric oxide, NO. Then now you know that nitrogen has 5 valence electron, outermost 5 electrons are there. Then out of 5, 2 they will make bond with oxygen. Oxygen has 6 valence electron. Then 2 electron of oxygen and 2 electron of nitrogen, they will take part in bond formation and double bond will form. Then now on oxygen, 2 lone pair of electrons are remaining, means 4 electrons are remaining on oxygen and 3 electrons are remaining on nitrogen. This is the, you can say, Lewis dot structure of NO. Correct? Then here you can see, if you will add 3 nitrogen, 3 electrons are remaining and double bond is in the middle between the N and O. Then count it. Octet is not completed. 3 plus 4, double bond is there. Double bond means 2 into 2, 4 electrons. Then 4 plus 3, nitrogen side, 3 electrons is remaining plus 4 electron, total 7. Octet is not completed. Between N and O, double bond is there, means 4 electron. 4 plus 3 for nitrogen, 7 electron. Octet is not completed. Only for oxygen it is completed. 4 plus 4, 8. Then in that molecule, in odd number of electron, this is not completed. Octet is not completed. Second example, that is a more difficult. Just like a carbon monoxide. Here concept is like yesterday I discussed carbon monoxide structure. Then here, like that way here also is there. NO2, N will be in the middle. Again 2 oxygen, one left side, other right side. Then you know that 1 oxygen and nitrogen, they will make double bond. Already I told you, discussed now only. 2 electrons from oxygen, 2 electrons from nitrogen, they will make double bond. On our oxygen side, 4 electrons will be remaining, means 2 pair of oxygen is remaining. Then from the oxygen side, 4 plus 4, 8. Octet is completed. But now see second oxygen, right side, between N and O, only one bond is there. They are making only one bond, single bond. Then here NO, then consider the nitrogen. Already 2 electrons they have shared with oxygen, with left oxygen. First one. Then now 3 electrons were remaining. 2 electrons they have used. Then now on nitrogen 3 electrons are there, because 5 is the valence electron. Then in that 1 electron, now they have shared with second oxygen atom, right side. 1 each. 1 oxygen and 1 nitrogen, both 1 electron shared and single bond is formed. Then now on nitrogen, 2 electron only is remaining, because 3 they have used, 1 pair is there. And oxygen side, because out of 6, 1 they have shared, then 5 is there. Here you understand, nitrogen has now 2 electron, because 3 they have used, and oxygen has 5 electron, 1 they have used in making bond between N and O. Right side, and 2 electron nitrogen they have used with left side oxygen, nitrogen in the middle. Then now see here only you have to understand. Nitrogen 2 electron is there on nitrogen remaining and oxygen 3. Oxygen 5. Then now see what will happen, how molecules exist. Octet is not completed, because total if you will count for nitrogen, then 4 plus 2, 6. 6 plus nitrogen, it looks that it is completed for nitrogen, because double bond is there, 4, 2 electrons, 2 bond means 4, and this side again 2, then 4 plus 2, 6, and 2 you can say this is there, lone pair. Hence, okay, in case of nitrogen and oxygen, left side oxygen and middle central nitrogen atom, it looks octet is completed. But real story I will tell you. Because left side oxygen atom, 2 pairs are remaining, means 4 electron and 2 double bond is there. Then 4 plus 4, 8. And for nitrogen, double bond they make, then 4 electrons and 2 lone pair, 2 electrons are remaining, means 1 pair, then 2 to 4, and again 2. Not 2, 4, 4 to 6 to 8. For nitrogen also it is okay. Because 1 pair is remaining plus 2 bond means 4 electrons, 4 plus 2, 6, and again right side they make a single bond, and single bond means 2 electrons. The nitrogen also looks, means it looks that it is 8, but I am telling you what happens. But oxygen side, you can see right side oxygen 5 are there, and 2 sharing if you will consider, then 5 plus 2, 7. Octet is not completed. For the right side oxygen, means second oxygen, octet is not completed, because 5 plus 2, only 7 are there. But NO2 all know that nitrogen dioxide exists. Then how? Octet rule, here it fails. Then now I am telling what is actually real story. Here what happens, nitrogen has 2 electron, means 1 lone pair of electron, useless. Lone pair electron, simply it is carrying. Then what happens? And oxygen is electronegative. Yesterday also I told you in case of carbon monoxide. Then same concept is here it working, that this oxygen is electronegative. I have 5 electrons. Then they will attract 1 electron from the nitrogen. See, both are electronegative, oxygen and nitrogen. But oxygen is more electronegative than nitrogen. Then that oxygen will attract 1 electron. Actually, there will be always competition, comparative. Which one is more electronegative? Then who is less electronegative, that will behave like a positive. And which is more negative, then that will behave just negative. Then like that way, they will attract 1 electron, then oxygen will get 6 and 1 minus. Charge is developed, and nitrogen is given 1 electron to oxygen, then nitrogen will get 1 positive charge. Then now on nitrogen only 1 electron is remaining, and now on oxygen 6 electron is remaining. Then due to this creation of charge, positive and negative, that attractive force will develop and bond molecule will exist. That's why question is asked, how molecules exist? Explanation in writing, where Indian examination, where written exam will be there, subjective what you are telling, there you have to explain why but now all examination have competitive this objective examination. Then there only you have to understand the concept and you have to answer. I am telling you, in examination only your concept will help you nowadays, because direct question only they are asking for normal examination, university examination. But in competition, now you know that it is nowadays competition is very tough. Then their intention is to reject the student. That's why they will ask tough question. Then concept will save you. Concept is very, very important. You can answer any question. Now this I have told you about the odd electron molecules. Then here NO2 I discussed. Then carbon monoxide, yesterday I was telling, there also you have seen 4 electrons were there, 2 electrons on that carbon and oxygen. Finally it was remaining. Correct? Carbon, oxygen, 2 finally it was remaining. Then there also same thing happened, because oxygen was electronegative, now that will attract 1 electron. They will get negative charge and carbon will get positive charge, and due to the attraction carbon monoxide will exist. I have told you that how carbon monoxide is existing. This question is also asked. Okay, then you should be careful in this type of examples. Now here we come third exception. Third exception is the expanded octet. The expanded octet. This is the third. What is that? Now try to understand. Elements in and beyond the third period, means third period onward, including third period. Elements in and beyond the third period of the periodic table have, apart from 3s and 3p orbitals, they have 3 orbitals also available for bonding. In a number of compounds of these elements, there are more than 8 valence electrons. Now I told you that sometimes octet will be not completed, incomplete means less than 8. Now in this case more than 8. That's why it is called expanded octet, due to this reason, because they have more than 8 electrons in the central atom. More than 8 electrons. Okay, and this is happening due to the 3d orbitals also taking part in the bond formation, means available for the bonding. Okay, then in a number of compounds of these elements, there are more than 8 valence electrons around the central atom. This is termed as expanded octet. Question is asked, what is expanded octet? Now you have understood, and here obviously the octet rule does not apply. Now here in just some example I will give you, and you can understand very easily. And I told you, just you try, you make habit to imagine in your mind, you make habit to calculate in your mind will be sharp, fit for the competitive exam. Always pen and paper, I told you, not given. Calculator also will be not, you can say, given. Then now you can see some example I am telling you, where this will be more than 8. Central atom will have more than 8 electrons. Then first example I am telling you that PF5, phosphorus pentafluoride, just like a PCl5, phosphorus pentachloride, same thing. You can take example of anyone, PCl5 or PF5, both belong to the halogen. Here P is in the central atom is P, and 5 atoms are surrounding. 5 fluorine atoms are surrounding. Then now, how many bond will be formed? 5 bond will be formed. 5 bond will be formed. Up, down, left, right, left 1, right 2. Total 5 bond will be formed. And 5 bond means 10 electron. 10 electron. Then now you can see around the phosphorus 10 electrons are there, mean more than 8. Here octet rule fails. Now second example I am telling you, SF6. S is in the central atom and 6 fluorines are surrounding. Means up, down 1, 1 and left, right 2, 2. Then 6 bond it will form by sharing of electron 1, 1 each. 6 bond into 12. Then here 12 electrons around the sulfur atom. Here also octet rule fails. Now H2SO4, third example, H2SO4. Then first you consider SO4. HH is there, that you can write later on in the end. Then here SO4, then 4 oxygen is there. Then S is in the middle. S is in the middle. Then with 2 oxygen, they will make a double bond. Up and down, oxygens are there. Then double bond. Correct? And left and right, single bond. Then now you can see up and down octet is completed, no problem. That sulfur upside oxygen, that is octet is completed because out of 6 electron 2 they have donated to make the double bond. Then 4 electron and 2 pair are remaining. Means 4 electrons are remaining. Then 4 plus 4, 8. Down also same things. 2 pair is remaining and 2 electron taken part with sulfur. Sulfur also has a 6 electron in valence electron. Then for sulfur also this is completed. 4 plus 4, 8. And oxygen also it is completed. Octet is completed. Means for sulfur means central metal, and for the 2 oxygen out of 4, 2 oxygen up and down, 8 is completed. Octet is completed. Now see where it is failing. Then here you can see it will fail with other 2, because left and right I am talking about oxygen. Then these actually oxygen, they are making single bond. Left and right they are making single bond. S and O single bond. Left side also, right side also. Then that oxygen, left and right oxygen, see out of 6 only 1 they have contributed. Only 1 they have contributed. Then 5 are remaining. 5 are remaining. Okay. Then 5, for this case it is not octet is completed. 5 plus 2, 7 only. Same things with left side. 1 they have completed, 5 oxygens are there. Then 5 plus 2, 7. Then this side, this is not completed. Octet is not completed. Okay. But if we will count sulfur, around the sulfur how many electrons are there around the sulfur? Then now you are understanding that 2 pair upside, 2 pair down means 4 plus 4, 8, and 1 pair left side, 1 pair right side, means total 12 electrons. Because left and right only single bond is there. Then here also octet rule fails. Here more explanation is required. Here I want to tell you that H2SO4 is there, 2H is there, hydrogen is there. What its role? Then here because it's acid means it liberates hydrogen. Any substance if liberates, you can say H ion in water, in solvent, then that is called acid. Then here 2H is there, then both H are attached with left and right oxygen. Then how? Then hydrogen has one electron. Each hydrogen has one electron only. Then oxygen will share one electron to hydrogen. Then covalent bond will form. One from oxygen, one from hydrogen. Then single bond will be formed. Then now on oxygen 5 electrons was there, now it became 4. Same way left side. One oxygen out of 5 electrons, one it will contribute to the hydrogen, and one electron from hydrogen, one from the oxygen, single bond will be formed. Then again on the oxygen 4 electrons will be left. Then now for your easy understanding I am telling you that now all 4 electrons, they have 2 pair of electrons in H2SO4. For remember, you can remember very easily, all 4 electrons in H2SO4 have 4 electrons, means 2 pair, all 4. But sulfur has 12 electrons. Here octet rule also fails. Then I told you about the 3 exception. But regarding the sulfur, one again only for sulfur I am talking about. Sulfur you have seen now that it has expanded, means more than 8 electrons they will have around the, when it is in a central atom, they will have more than 8 electrons. But sometimes they will have only octet. Okay. Then example is such type of where they will have octet, that is the SCl2, thionyl chloride. What you are telling? Thionyl chloride. Here S, sulfur also has a 6 valence electron. Then then one electron they will make a bond with chlorine atom, sharing one from the chlorine, one from the sulfur, and single bond. Then out of 7, now on chlorine 6 are remaining. Both chlorine 6 are remaining, and on sulfur valence electron is 6. Then 4 is remaining because 2 they have used in making the bond with one each with the chlorine. But in this case octet is completed because 2 pair is remaining, means 4, and 1 pair with chlorine atom, left side right side 1 pair, means 8 electrons. This is the exception where sulfur is maintaining 8 electrons. Now I want to tell you that drawback of octet theory. 3 drawbacks are there, just to understand. It is clear that octet rule is based upon the chemical inertness of noble gases. However, some noble gases, for example xenon and krypton, also combine. See, xenon and krypton, they belong to noble gases. They should not react because they are inert gas, but they are also reacting, also combined with oxygen and fluorine to form a number of compounds like xenon fluoride XeF2, KrF2, xenon fluoride, krypton fluoride, xenon oxyfluoride, means XeOF2. These 3 examples what I told you, it asked in examination, examples of, you can say compounds, examples of compound which xenon, krypton they are making. What I mean, this is called Actually, not only this noble gases. Noble gases, I give an example, they are making compound, but exception is there. They can't make compound with all, only with most electronegative element. Most electronegative element, like fluorine. See, in all fluorine is there. Gen fluoride, krypton fluoride, Gen and oxyfluoride. Oxygen is also electronegative. It is a second position in whole periodic table. Fluorine is the most electronegative. Second is oxygen. Third is the nitrogen. And after that, these things, this bromine, iodine, like that. Okay, this question is also asked. Arrange the electronegativity. Then first fluorine, second oxygen, third nitrogen. They are decreasing. After that, bromine, iodine, starting like that way. Now, here I given 3 examples for these things, noble gases which are making compound with fluorine and oxygen. Now, I was telling you that not only noble gases, again I am telling advanced knowledge, that interhalogen compounds is also formed. This is for BSc or honors, and IIT also question is asked. Interhalogen compound, they themselves will make a compound among themselves only, halogens. Then how, on what is the basis? Then you understand which is more electronegative. They will take the electron, they will attract electron from the less electronegative. Like as for example, fluorine and chlorine, they can make, or fluorine and bromine, they can make, because fluorine is most. It can take electron from the chlorine also. Here not completely they will take, but they will attract. They will attract fluorine, chlorine molecules also, atom also, electron of the chlorine. They will attract electron from bromine, they can attract electron from iodine, they can attract. IF7 is the example. IF7, heptafluoride, iodine heptafluoride is the example. Here fluorine attract the electron of iodine. Okay, this is easy for them. Actually nearby they may not lose very fast, but they can lose, they can attract. But as the distance between two will be more in halogen group only, then they will attract easily. Okay, then I told you not only noble gases, halogen also, they are making interhalogen compound. Internoble gases, I told you, they are making compound like that way. This question, both questions are important for IIT advanced. Okay, then now second exception I am telling you, Octet rule limitation, not exception, limitation. This theory does not account for shape of molecules. Octet rule, they are not telling any about the shape. This is the second limitation. Third limitation, it does not explain the relative stability of the molecules. Molecules are stable or not, or unstable. They are not telling anything. It does not explain the relative stability of the molecules. Okay, being totally silent about the energy of a molecule. They are not telling about the energy is more or less. Then this I have discussed, I can say, drawback of the octet theory. Today I am stopping only here. Next class again I will meet you. Thank you.